Today's lesson we're looking at inequalities. So this is very similar to linear equations that we've done before, except instead of saying that x is equal to something, we can say that x is greater than or less than, or maybe greater than and equal to something, or less than or equal to something. In specifically, we can look at it graphically. So we've got this first sort of number line situation here. We've got a open circle, then a line that goes at the end to an arrow. This means that x is greater than a, not equal to it, and that it goes off into infinity. The next one here, it says that x is greater than or equal to a, and that's with a little closed in dot. The next one, we've got x is less than a, so we've got a circle with an open dot that goes off to the left, and then x is less than or equal to a, and that's when we have that closed in dot. It means that x is equal to a. Okay. The less than or greater than without the equal means that x gets really, really close to a, but never actually reaches it. The last line here is we've got an interval. So x is between a and b. Here we say that a is less than x, which is less than or equal to b. So we've got an open circle at a and a closed circle at b. Solving linear equalities, exactly the same as equations. The only rule is that we reverse the equality sign if we're multiplying or dividing by a negative number, or if the sides are switched. Okay, now let's have a look at some examples. We've got example 12 here, a. We want to write this as an inequality. So we look at our lower bound first, so that's 2. We can say that 2 is less than, it's not going to be equal to, and then we write x there. For b, we can say that x is going to be between these two values. So we've got -3 and we've got 0, and then x is going to be greater than or equal to 3 because we've got a closed dot, and then it's less than 0, it never actually reaches 0, it's not equal to 0. And then lastly, we've got x is going to be less than or equal to 6. And we'll just go off. It can be any number that's less than or equal to 6. All right, now let's have a look at some solving. Okay, we've got 3 examples here. We've got one that just looks like a normal linear equation. We've got one that with a bit of a fraction in it, and then one with x on both sides of the equation. Really straightforward. Let's do a first. Alright, so we've got 3x plus 4 is greater than 13. Now we know how to solve these. We do the addition and subtraction first. So we're going to take away 4 from both sides. So we're left with 3x is greater than, well, 13 minus 4 is 9. There we go. Now we've got 3x, we just want 1. We're going to divide by 3. So x is greater than 3. That's 9 divided by 3. Done. If we want, we can graph the solution now on a number line. We can draw a line, make sure we put arrows at both ends. We've got x is greater than 3. So I'm going to put a 3 down. Oops, I'm going to put it on the bottom. 3 here. Then I'm going to use red. Now it's an open circle because it's not equal to 3. And x is greater than. So I'm going to put a line that goes off that way and an arrow on the end. All done. Next one, b. We've got 4 minus x over 3 is less than or equal to 6. Alright, usually I like to get rid of the fraction first. So I'm going to multiply everything by 3. I'm going to have 12 minus x is less than or equal to 18. Gets rid of the fraction, makes everything easier later on. Now, because I've got a negative x here, okay, I could add it to both sides, but I want to demonstrate one of the rules we said earlier. So what I'm actually going to do is take away 12 from both sides. I'm going to be left with negative x on the left is less than or equal to 6. 18 take away 12 is 6. Now, I don't want negative x, I want positive x. So if I multiply both sides by a negative number, in this case -1, I have to flip the equality sign. So instead of saying negative x is less than or equal to 6, positive x is greater than or equal to -6. And then again, we can graph this on a line. So we put an arrow on both ends. It's going to be greater than negative 6, so I'm going to put negative 6 on the left here, and then I'm going to use a coloured in dot with an arrow going to the right. Alright, last we've got C. We have 3x plus 2 is greater than 6x minus 4. And I'm actually just going to scooch this one down to a new page so we've got some space. Alrighty. So 3x plus 2 is greater than 6x minus 4. Check I've written that correctly. Yes. Alrighty. I've got more 6's on the right-hand side, more x's on the right-hand side of the equation. So I'm going to move my 3x over to the right. So if I take 3x from both sides, I'm left with 3x on the right, because 6x take away 3x is 3x. And then I've got to take away the 4. Awesome. Now I'm going to add 4 to both sides. That'll give me 6 is greater than 3x. And now I've got to divide by 3 just to isolate my x there. 6 divided by 3 is 2. Therefore, we have 2 is greater than x. And if I want to demonstrate the other rule, if I wanted to have x on the left, 2 is greater than x. That means x is less than 2. If we switch sides, we switch the equality. Awesome. And lastly, we just got to sketch this on a number line. X is less than 2, so I'm going to put 2 over on the right here, and it's an open circle and a line to the left with an arrow on the end. There you have it. That's linear inequalities. Very similar to linear equations and solving them. Just make sure you remember those two rules. If we swap sides, we swap the equality, and if we multiply or divide by a negative number, then we switch the sign as well. Awesome. Do questions 1 to 7 from chapter 1D in your textbook, 1D. And then I'll leave the video just up the top here if you want to copy this down in your books. Good stuff.